So our next speaker is Mr. Elia Brodsky. Mr. Brodsky is one of the co-founders and CEO of Pine Biotech. He has facilitated and managed collaborations with researchers at Stanford, UCSF, Louisiana State University, Tulane, and other academic and pharma R&D teams. Mr. Brodsky oversees the research projects and manages the development of the prototype, preparation of relevant data projects, and implementation of the system for the needs of the students and teachers that the project is designed for. So please join me in welcoming Mr. Elia Brodsky.
Thank you very much again. Congratulations to everyone. And it's really exciting to see how all of this actually connects. And I'm really pleased to be a part of this symposium today. And what I want to share with you today is actually how we're going to continue and expand the OmicsLogic program. So what we saw in the past couple of days are the multiple directions that bioinformatics can play a role, from precision medicine to pharmaceutical companies, biotechnology companies, astrobiology, origins of life, right? It's not really a domain-specific discipline, but it empowers researchers in many different directions. And so what I want to talk to you about today is first, how did we establish this program in the first place, where it's going, and specifically focus on one aspect, which is the program that we're developing together with the National Association of Idea Principal Investigators. So the National Association of Idea Principal Investigators is a network of idea-funded PIs. IDEA program is an NIH-specific program designed to elevate biomedical research. And so what is common across all of these different states that you see on the map is that they don't receive as much funding as some of the hubs. But I think that actually speaks to a general problem that is also beyond the United States. Unfortunately, the money is not equally distributed across all institutions. And so I think in the US, it's exciting to see how special allocation of funding is making high-level research possible in these states. But if you go to, we're located in New Orleans in Louisiana right here. And if you kind of compare how things are done here, you might see a lot of differences between, let's say, what's happening in Boston, Massachusetts, San Diego, or San Francisco, and what's happening here. And similar to what others experience around the world, there is a challenge to attract talent, and there's a challenge to make this talent work together, focusing on local problems and accelerating research that addresses local issues. And that is what this program is specifically designed to do. The funding, the IDEA funding, is really designed to help establish sequencing centers, cores, really enabling technologies so that other researchers that are striving to pursue advanced topics in different areas of research, especially biomedical research, can be successful. And across all of these states, there's a need in bioinformatics. So over the course of the past just several months, we've started a pilot with the National Association of Idea Principal Investigators to design a resource and implement programs to support training in biology as a data science. So I'll briefly talk about OmicsLogic for anyone who's here and who's not heard about it previously. So OmicsLogic is a portal designed to kind of combine multiple things that we saw today. And it starts from a portal that you can find on this link, learnomicslogic.com. You can register for free, and you become a part of the community once you register. It's a free registration. You get access to not only free resources, but importantly, a network that we're building. And I think a network that you have seen today that combines experts, students, faculty, researchers, and others. And importantly, what this portal allows us to do is it allows us to combine the learning and the research around a personal profile. So in the personal profile, we've designed elements like sharing about your background, connecting your social media, tracking your progress of learning, badges for different programs that you complete. And it allows the faculty to see how the progress in your learning matches with the objectives of whatever the program pursues. So importantly, we've designed a process of certification that actually allows us to make sure that people, when they become interested in a particular area of research, are actually ready and prepared and informed to apply bioinformatics in a meaningful way. And so after you receive this basic certification, then the next step is to make sure that your profile is complete and you're able to pursue your research topic, your idea. So some of the projects that we saw yesterday in the poster presentation, today we had Dr. Imanturia and Ojasvi. So they were a part of the research fellowship, and actually many, many more students participate in this process every semester, attempting to complete novel, independent, or group projects using publicly available data. And so we've built this format because we think that, beyond certification and kind of basic skills, really the validation that you know something is when you can apply it to something of your own. And because bioinformatics is such a diverse and dynamic field, because natural interests are so different, we cannot design programs around everything. So we're opening it up for anyone who would like to pursue a project to really be able to do that in a reproducible way. So once that is done, we are actually going to do biannual events like this one to bring the community together, select the most promising projects. And one of the things that we would like to do is actually turn those projects into opportunities for others to learn. So it's not just a way to learn and develop your own research, it's also a way to contribute and share what you have done with the broader network and the community. Beyond this, with this expanding library, and I want to pause here, by the way, and say that one of our objectives in the next few months is to open this platform to other contributors. And we've started working with several programs around the NAIPI Southeastern region to start working on new materials to add to the library that we've developed so far. And this is going to be around several different basic topics like genomics, transcriptomics, metagenomics, or epigenomics, data science, and a general free course that we're going to make available for anyone to kind of take and use as they need, called Introduction to Bioinformatics, or Bytes and Molecules. And so that is really one aspect that I wanted to highlight today, is that one of our missions as a company is to make bioinformatics more accessible, make it easier to participate in, make it easier to apply it practically, and make it easier for someone who does not have any technical background to really benefit from it as soon as possible. So in a faster way to kind of appreciate the role and the meaning of bioinformatics. And so for that, we are creating this free resource. Anyone can use it. Anyone can, as a faculty, use it as a resource for teaching. And in fact, we're going to start a partner program that it will allow for the more advanced topics to follow after this brief and maybe optional introduction. And one of the things that we're going to include in this package is not just the basic modules like Introduction to Bioinformatics or Bytes and Molecules, or getting started with bioinformatics in R and Python, but importantly, provide a view of these many different topics like we heard in the past couple of days. How is bioinformatics used in precision medicine? How is bioinformatics used in astrobiology? How is bioinformatics used in pharmaceutical companies? Drug discovery, all of these topics, they are the things that drive bioinformatics forward, right? So bioinformatics, I think, is not driven by just computational and algorithmic innovation, but primarily it is driven by people that understand the data challenges that these domains bring. And so another part of what we are really passionate about as a company is not just the diversity of bioinformatics applications, but also how these bioinformatics methods and tools are used by experts. So obviously, it is great when we can have speakers like her today and yesterday come and present a topic that they have been studying for decades. But I think it's equally important to appreciate that even these presentations are based on a hypothesis that has been addressed in some way with evidence, but also reviewed by peers, by the broader community. And so that's why the key, we believe, is to focus on publications. So these peer-reviewed publications that we can review and extract kind of the methodology used by experts, including data that was submitted by them and made publicly available, is the foundation for these courses and projects that we develop on this portal. So the portal really provides 6 basic courses that anyone can take and kind of we standardize and make sure that we improve the content of these courses that include Introduction to Bioinformatics, Genomics, Transcriptomics, Metagenomics, Epigenomics, and an Introduction to Data Science. And on top of the basic level, we actually introduce specialization tracks. And this is how bioinformatics is used in oncology, in infectious diseases, in neuroscience, and in agriculture. And I'll talk a little bit more about some of these upcoming programs in the next few slides. What's important, though, is that as a part of this coursework, we have a package of enabling technologies. And these enabling technologies are designed to, again, lower the barrier for entry, speed up the process of going from base to more and more complex topics, and be able to identify the best track that fits your current stage and your objective in the future. What do I mean by that? A lot of students might be pursuing bioinformatics as a degree, but I think an even greater proportion of students are not directly interested in bioinformatics. And so for many, as we've seen yesterday especially, this interest in bioinformatics is something that shapes over the years. And so it's not appropriate to dump all the complexities and kind of the requirements for coding languages and statistics right up front in that process. And so we try to present a variety of paths that you can pursue to be able to analyze data and make discoveries, which is the exciting part. And if you choose to do so, enough depth for you to also learn how to develop your coding skills, how to get certified in different levels of biostatistics or machine learning, and even how to pursue a more technical resource for cloud computing, for example, as we will hear today as well. So one important aspect of this is that we have code and no code bioinformatics paths. And that means that you can either perform analysis using the big data analysis T-Bioinfo platform. And we've heard today about new sections on this platform. It's a dynamic place where experts contribute new and more efficient workflows, as well as learn languages like Python and R to learn how to program your own or use existing packages. And so in a variety of domains, I think that you will see how bioinformaticians range from biologists that are experts in using these packages with understanding of the different settings, with understanding of when to apply what kind of methodology to answer a specific question, as well as those that go the technical route, and they are able to engineer novel applications and make these applications user-friendly and more efficient for discovery. So with that, I think that, I'll briefly now speak about several different programs that are coming up that you can participate in. And we have our team here with us. So if you are interested in any of these topics as a faculty or as a student, I encourage you to reach out. And at the end, we will share some of the contact information for you to be able to connect with the right person. I think there are exciting many new ideas and challenges arising in the field of gene expression and transcriptomics. And so traditionally, we've run a program called transcriptomic data analysis, or RNA-seq, where we explored bulk RNA sequencing, and the volume of bulk RNA sequencing has really been growing over the years. So at the foundational level, it was always important to understand what is RNA sequencing, how do these next generation sequencing technologies work, what are some important methods to explore and understand this kind of data, design statistical hypothesis testing techniques. And as of recent, it's been really important to also understand the differences between bulk RNA sequencing and single cell RNA sequencing, which is a technology that is becoming more and more popular and applicable in many different domains. So we've designed a program and standardized it to include some specific aspects that can be taught either in a short setting where face-to-face students meet, or supplement that with asynchronous training exercises that one can complete both on the OmicsLogic portal and utilizing the Bioinfo platform. So for that, we again have a section. The section is color-coded and explained, and it really covers how you can analyze data from understanding the inputs and outputs to the logic behind the analysis that is color-coded and explained in detail. Why do we have to perform each one of the individual steps? And I think what we've seen as a result of doing this program multiple times is how this approach helps students appreciate how any kind of analysis can be structured in a very logical way. After they understand the logic, we then introduce a variety of different types of projects where they can see the application of RNA sequencing techniques in oncology, in precision medicine, in infectious diseases, and epidemiology. With the popularity of single cell, we've seen a kind of like an expectation that this is just exactly the same as bulk RNA sequencing, and it really is not. There are a lot of new methods, there are a lot of specific approaches, and a lot of emphasis is put on downstream interpretation. And so as we have heard today, now we have a full section that kind of automates and simplifies the downstream analysis of single cell RNA-seq data using such packages like Seurat and Monocle. And importantly, we provide a step-by-step breakdown of each one of these logical steps using exercises that you can perform independently. And I'm excited to say today that this course is also available, and anyone can find that course on the OmicsLogic portal. Obviously, supplementing the basic training with project examples is a big part of what we are trying to do. And so we take these publications that have an impact in this domain, and we break down the methodology portion and really describe how one can analyze such data and replicate an analysis found in a publication. With so many different types of omics data, now it's important to not only understand how to process, analyze, and visualize a single type of data, but importantly, integrate multi-omics data as well. And that's a big part of what we do on this portal, is introduce multi-omics integration methods that could be contrasted and compared and applied in specific domains with a benchmark. So an important part of what we do in the projects are curated data sets that one can use to establish an understanding and really test how well you apply the methods to get the same results. As we've seen over the past 2 years, infectious diseases, from being kind of a domain that suffered from a lack of funding, became a domain with exciting new research and applications that touch the lives of all of us today. And so back in 2020, we launched our Bioinformatics for Infectious Diseases program. And we quickly adapted that program to address the challenges around COVID-19, so that not only we're able to understand pathogens and kind of study those pathogens using project examples, but also think about applications. And I'll briefly kind of mention a couple of these applications that we've seen resulting from this program. So as a result of understanding the methodology and seeing how next generation sequencing can be used to study these viruses and different types of infectious diseases, we have developed a number of collaborations around wastewater sequencing of COVID-19, monitoring variants of concern and other types of strange phenotypes that have been reported in literature. And I think that this kind of interest in bioinformatics as a result of the pandemic, of course, the pandemic in itself was an unfortunate event that we're still not out of, but I think it really gave a lot of popularity to terminology, methods, and even types of data that will, in the future, I think this generation that went through this pandemic will be so aware and so familiar with some of the methodology that they will be able to address future challenges of similar character in a much more effective way. And so we've designed several project examples, a variety of different viral epidemics, and an in-depth training resource for SARS-CoV-2, where both consensus level and sub-consensus level analysis could be performed, not only at the sequence level, but importantly also translating the sequence level to the immunology and to the protein-protein interaction level. So looking at 3D structures of proteins and understanding how they have an effect on vaccine design and protein-protein interaction. And so really at the core of this, I again want to emphasize how significant it is that this is available not only for engineers. The T-Bioinfo platform really hides the complexity of analytical pipelines and complex algorithms that have been developed by experts in the field to make it possible for someone who's a student or a biologist or a biochemist to apply these complex methods and understand how they are used with practical examples. So methods like processing FASTA and FASTQ files for multiple sequence alignment and comparative analysis of different sequences, reporting, generating a full report on variants of concern found in different types of viral populations, understanding how this data can be visualized effectively and presented. And also importantly, as I mentioned, mapping the mutations that we identify and understanding how they impact different aspects of immunology. During these exercises, we actually also look at protein-protein interaction, really trying to understand the available resources like protein crystallography, but also how to connect the different types of data and really understand the way that multiple sources of data could be used together. Now, yesterday we spoke with Dr. Sona Vasudevan from Georgetown University Medical School, where she leads a program on systems medicine. And together with her team and her students, we've developed this program specifically to introduce a non-engineer to the basics of data science and machine learning using R and Python. I think that it's a very critical skill for anyone to learn how to code. And I think that it's non-trivial for someone who doesn't come from an engineering background to do so. But we've seen how these resources can make it much easier for someone to learn how to code quickly and develop a practical sense of the application of languages like R and Python to address bioinformatics challenges. And so the exercises that we have available on the portal include mapping mutations for metabolism of different drugs, really learning how to code from a syntax perspective, from the perspective of data visualization, and the application to many different types of data, such as genomic data analysis, metagenomic data analysis, as well as different types of big data repositories that could be explored and visualized using such tools. To summarize, I think that what we have seen is an explosion of interest in different domains, starting from very basic usage of genomics in the lab to such interesting concepts like spaceomics. And when I mentioned that we're opening this platform to other contributors, this is really what I am implying. In different universities and different labs and in different research fields, experts have dedicated years, if not decades of their life to identifying important topics and learning how to address them in a reproducible and high quality way. And we would like to kind of establish a way for those experts to be able to take their expertise and allow us to design high quality training materials that could help effectively many of the people that are locked out of these domains to be able to participate by first learning about these topics and then knowing how to apply their skills and their insights and innovation and maybe creative thinking to address the topics that are pressing and urgent in each one of these domains. So we have these programs on cancer biology, precision medicine, spaceomics, and many others. And we're excited to share with you that these types of programs have already impacted hundreds of students in Louisiana, thousands of students around the world, and we're hoping that many more across the National Association of Idea Principal Investigator Network as we are completing our first pilot, which lasted from January until the end of March, so until yesterday. So with that, I am going to be available to answer any questions. If anyone had any questions, I'm going to share my email address. If you would like to reach out to me, I'd love to talk to you about these programs. I've shared my email in the chat. We will have a few more speakers from NAIPI speaking about different efforts that we are going to kind of combine into this program as well. I thoroughly enjoyed seeing some of the results that we have seen, and I think that is really the demonstration of what we are trying to do, some of the research projects that we've seen from the students. So thank you again.
Definitely. Okay. Thank you very much.
Of course.
Well, that was, again, a great talk by Dr. Trubel.